All right, so we are looking at surface area and volume of prisms and cylinders. Guys, this is not hard, but if you are struggling with finding the area of a typical figure, then finding surface area and volume is going to be difficult also. However, I'm going to show you the easiest way to do these. And if you'll just do them the way that I'm showing you, you will be fine. But if you try to go off on your own, thinking that you have a better route, then that's where you're going to mess up, because I've been doing this a long time. I already know the corners that need to be cut, and I am showing you that. Understand? Okay. First thing we're going to do, we're going to just real quick refresh our memories on what we did last time. Okay. So we are going to shade the bases and name the figure. So first thing that it says is the number of rectangles. So first we need to shade the base. Well, there are exactly 2 triangles. So that is going to be my base, because by definition, a prism, because that's what we're doing today, is prisms and cylinders. So there are 3 rectangles because there are 3 lateral faces, because there are 3 sides of a triangle. There are 2 triangles because that is the base. And this is a triangular prism. Okay. Number 2, my bases. What you do is you look and see if you find 2 exactly the same things. There are 2 circles because this is a cylinder. Here we're going to have 5 rectangles because a pentagon has 5 sides. So my base is a pentagon. So that means I would need to find the area of my pentagon in order to find my surface area and volume, because this is a pentagonal prism. Now, when you're looking at your formula chart, okay, when you look at surface area and volume, you see there's P's, there's H's, and there's B's. That's all that's really located here, other than your radius and your height, okay? You see a lot of P's and a lot of B's. Well, that's because P is for the perimeter of the base. So this figure right here that we shaded, oops, and I didn't do it on this one. Okay, whatever it is that you shade, that's what you need to find the perimeter of. So this is the perimeter of the base. Big B stands for the area of the base. So now let me show you the very easiest way to do this, okay? So first thing we need to make sure we understand is the difference between surface area and lateral area, okay? Surface area is total area, okay? Surface area means total area, okay? That means bases and faces. Lateral area is just area of the faces. So if it's a prism, then you're just finding the area of the rectangles, okay? So this is just area of the faces, no base. All right. So number 6, we have exactly 2 triangles. So this is a triangular prism. And the beautiful thing about this particular problem is it is an equilateral triangle. I'm going to show y'all this beautiful triangle formula for equilateral triangles, okay? So I want you to go to your formula chart. So right here where it says area of a triangle, I want you to put capital A, little e. The little e means equilateral, okay? You need to make yourself a note here. It means equilateral, okay? I want you to put s squared square root of 3 over 4. So write S3 square root of 3 over 4. We're going to use this formula on our equilateral triangles because it's going to make our life a whole lot easier, okay? It's going to be easier than base times height because I don't have to worry about finding the height. I don't need it. I have the side. Make sense? All right, so here we go. When you are finding the surface area and the volume of a prism or a pyramid, okay, I have a set pattern that I go by, and I need you to follow the same pattern. So the first thing you're going to do is you're going to write P, B, H. All right, so P, B, H. All right. P is the perimeter of the triangle. Big B is the area of the triangle. H is the height of the prism. So how far apart are your triangles? So this is your height. So we already know 7.2. And I'm going to tell you guys, once we have these three numbers, you're going to be able to find surface area and volume, no time. Okay? So first, perimeter. So perimeter of the triangle. So since it's equilateral, there are three sides. Each side is 4. My perimeter is 12. Now, to find the area of this triangle, since it is equilateral, I'm going to use that formula, S squared square root of 3 over 4. What is the length of the side? It is 4. So that means 4 squared square root of 3 divided by 4. 4 squared is 16. So I've got 16 divided by 4 is 4 square root of 3. So this is your big B right here. That is your big B. So now the fun part. Lateral area is PH. Lateral area is PH. It says so right here. The lateral area of a prism is PH. We have a P and we have an H. 12 times 7.2. So this is 86.4. And this is inches squared. Surface area is your lateral area plus 2 B's. So that's 86.4 plus 4 square root of 3. So you already have your 86.4 in your calculator. Add 4 square root of 3. So that's 96.3 inches squared. Volume is BH. Well, B is 4 square root of 3. H is 7.2. 4 square root of 3 times 7.2, 49.9 inches cubed. And that's all there is to it. All right, next we're going to do a rectangular prism. So I'm going to block this off here where I don't get anything mixed up. So what I'm going to do is I'm going to find the perimeter of the base, area of the base, height of the prism. All right, so what I'm going to do here is I'm going to say that the bottom is my base, which means the top is also my base because there's 2 of them. So the distance between them is 3. So the height of my prism is 3. So now I need the perimeter. Okay, so the perimeter, 6 and 6, 12 and 12. So 6 plus 6, 12 plus 12. Well, 18 and 18 is 36. So my perimeter is 36. The area is length times width. So 6 times 12, that's 72. So I have P, B, and H. Guys, I'm telling you, if you will get the P, the B, and the H, the rest is a cakewalk. This is going to be the hardest part. This little box right here is chapter 11. This little box is chapter 11. If you can't do chapter 11, you can't do chapter 12. Got it? All right, so here we go. Lateral area is PH. 36 times 3 is 108 centimeters squared. Surface area is lateral area plus 2B. 108 plus 2 times 72. So that's 108 plus 144. 252 centimeters squared. Volume, BH. 72 times 3. 216 centimeters cubed. Oops, sorry about that. It is hard to stay zoomed in and in screen. Now to do the lateral surface and volume of a cylinder, all you need is your radius and your height, okay? As long as you have those two things, you don't need P, B, and H because there is no perimeter. So those are the two things that you need. Lateral area, 2 pi RH. So that means 2 pi RH. And then just type it in and hit enter. 2 pi RH. So 339.3. 339.3. This is inches squared. And guys, these formulas right here are straight from your formula chart. Okay, the lateral area, the surface area, the volume, it's straight from your formula chart, okay? I'm not magically making them up or memorizing them. They're right there on your formula chart. Surface area is lateral area plus pi r squared h. Oops, lied. 2 pi RH. So lateral area we said was 339.3. Okay, remember lateral area is that one right there. Plus 2 pi 3.6 squared. So now we still have our previous answer there. So plus 2 pi 3.6 squared. So 420.7. So 420.7 inches squared. And then our volume, pi r squared h. Pi r squared h. Pi r squared h. Just like it looks on my paper. 610.7 inches cubed. So you just found 9 different answers in a fairly small spot. I'm going to do a problem with you that's not just a triangle or a rectangle. Because obviously when you start doing your assignment, when you take a quiz, when you take a test, it's not just going to be triangles and rectangles. So what I want you to do is to draw a pentagon. Okay. And I know this is going to seem super weird, but we're going to need to draw 2 of them so that we can make a prism. And it's going to be a little, it's going to be a little bit awkward. Just try to draw 2 of them, kind of spaced out like I did mine here. Okay. And remember, this is an art class, so they don't have to be perfect. They just need to make a little bit of sense. Okay. We're going to connect this corner to this corner. So basically attach your corresponding corners. This corner is going to attach to this one. This one's going to attach to this one, to this one, to this one. Now we have a pentagonal prism.
What does that mean?
Connect your corresponding corners. Okay, now, let's say that, okay, it's got to be a regular. Okay, it's going to be a regular. So we'll even call it a regular pentagonal prism. That means a regular pentagon. We're going to have to use PA over 2. So let's say that the sides of our pentagon are, so we're going to look at this pentagon right here because we only need 1 of them. Oops. All right, so let's say that the sides of our pentagon are 8. And so let's say the height between them, we'll go with 15. So in order to find the area, the surface area and volume of this pentagon, this pentagonal prism, I need the perimeter of the base, I need the area of the base, and I need the height of the prism. So one thing we know for a fact is the height of the prism is 15. That's the distance between the pentagons. So we're going to put 15. The perimeter, well, there's 5 sides. Each side is 8. So the perimeter is 40. What I need to do now is find the area of this pentagon. So that means we have to use perimeter times apothem divided by 2. Well, we just found the perimeter to be 40. So all we need now is this apothem right here. That is your apothem. Okay. So if you will try to recall, if you draw the radius, you get a right triangle in here. And we know that this piece right here is 4 because the apothem cuts it in half. I know this angle right here is 36 degrees because 360 divided by 5 is 72, and half of that is 36. So if I drew another radius, the whole thing here would be 72, but I only need this piece right here. So what I can do now, if you look, I'm going to redraw that right triangle so we have a better view. I'm looking for the apothem. That's 36 degrees. This side is 4. You can do tangent to get your apothem. The tangent of 36 is opposite over adjacent. So that means my apothem is 4 divided by the tangent of 36. Make sure I'm in the right mode. 4 divided by tangent 36, so 5.5. My apothem is 5.5, which is what I need right here. So sometimes big B is not going to be as straightforward as a rectangle or an equilateral triangle. Sometimes big B will require you to do some work. So type it in. 40 times 5.5 divided by 2 is 110. So now you have PBH, lateral area, surface area, volume. This part right here, I'm not going to lie. This part is going to take the longest, depending on what your shape actually is. But you have to know how to find regular area, just like anything else. pH, pH plus 2B, pH. Plug and chug. Oops, wrong way. 40 times 15. 600. This is 600 plus 2 times 110. So 600 plus 220. So this is 600. This is 820. And this is 110 times 15. Lateral area, surface area, volume. This is units squared because I didn't identify them. That's units squared. This is units cubed. All right, here it just says to find the volume. So all we're going to do is find the volume. So we don't have to worry about perimeter when you're doing volume because all it needs is the area of the base and the height. So BH is all you need when you're doing volume. H is the distance between, so that's going to be 5. In this particular problem, to find the area of the triangle, you're just going to do base times height because they're giving you the base and the height. So clearly you want to use the formula that makes it easiest. So 1/2 BH. The base is 3. The height is 1.5. Comes to 2.25. So your volume, 2.25 times 5. Is 11.25 centimeters squared. So pi r squared h. Pi r squared h. My radius is 2.5. My height is 7. All you have to do is type it into the calculator and hit enter. Pi r squared h. 137.4 inches cubed. All right. Now, just like before, when we did composite figures, you know how we were like, okay, that has a square in there, there's a triangle in there, there's a rectangle, and we just added all the different areas together, and then we were able to get our total area. We're going to do the same thing, okay? But if you'll notice, it's kind of like saying you have a can, because a can is a cylinder, sitting on a table, right? So when your can is sitting on the table, you don't see the bottom of your can. You also don't see the circle that the can is covering up on the table either, do you? So that means that if I were going to find the total surface area of the can and the total surface area of the prism, then I would need to subtract 2 circles to accommodate the bottom of the can and the part of the table that it covers up. Does that make sense? So let's do the surface area of our cylinder. So the surface area of our cylinder is 2 pi r h plus 2 pi r squared. And then let's do the surface area of the prism, which is pH plus 2b. So let's just do the cylinder first because they are so much easier because you only need a radius and a height, okay? So 2 pi r, which is 1, and then our h. So the whole thing from top to bottom is 8, but it's 2 up to this point. So that makes the height 6. So 2 times 1 times 6 is 12. And 1 squared is 1 times 2 pi. So 14 pi. So the surface area of the cylinder, so this is our cylinder, is 14 pi. The surface area of this thing over here, well, we need the perimeter of that. What is the perimeter of that? So 4, 4, 4, 4 is 16. The area of the box is 4 times 4. The height of the box is 2. So now let's plug those 3 numbers in over here. So we got 16 times 2 plus 2 times 16. That's 32 plus 32. That's 64. So this is the prism. So let's add these two together. And then let's make sure we subtract this circle 2 times because we don't see the bottom. So we've got 14 pi plus 64 minus 2 circles. Well, guys, isn't this part right here 2 circles? And that's 2 pi, isn't it? So let's subtract 2 pi then. So let's go. 14 pi plus 64 minus 2 pi, which is 101.7.
I got 101.6.
0.69. Yep. Now, could we have just eliminated those 2 circles in the beginning? We could have, but seeing it this way helps us understand and helps us see what we're doing, okay? All right, the last part here is talking about changing dimensions. It wants you to talk about when you double the linear dimensions, what happens to the surface area, all right? So let's find the surface area of the cylinder. Like I said, the surface area of cylinders are easy. So we got 2 pi RH plus 2 pi r squared. So I'm just plugging in the radius and the height into the formula so I can get the surface area. And then I'm going to double my dimensions and see what happens. So this is 2 times 2 is 4. 4 times 8 is 32 pi. 2 squared is 4. 4 times 2 is 8 pi. 32 and 8 is 40 pi. So this is feet squared. So the surface area is 40 pi. So they're asking me, well, what's going to happen to the surface area if I double my linear dimensions? Okay, so if I double this, what's it become? So it becomes 4. And if I double this, it becomes 16. So let's do this formula using 4 and 16. And then let's compare those surface areas and see what happens. So 2 pi 4 16 plus 2 pi 4 squared. So 2 times 4 is 8. 8 times 16 is 128. So this is 128 pi plus 4 squared is 16. 16 times 2 is 32. 128 plus 32 is 160. And this is feet squared. So obviously, if the dimensions became a bigger number, then the area became a bigger number also, right? But how much bigger? Because it wants to know how. Okay, so this is what you do. You take the 2 and you divide them into each other. So the pi's cancel. So the zeros are going to cancel. So 16 divided by 4 is 4. So it's 4 times bigger. So it is 4 times bigger. So if you double the dimensions, you quadruple the area. Okay?